All right. Well, good afternoon, everyone. So today is going to be our last proper lecture for the course. It's such a weird feeling to finally be at the end. Also to start thinking about planning for next semester, because I get to teach 104 again next semester too, which will be really exciting. So we had left off, we were in the middle of talking about problem solving. So as I mentioned, this chapter transitioned from talking about language, and then how language sort of affects our way of thinking, and then we've transitioned over into problem solving. And so we had been looking at sort of different barriers to effective problem solving, and we had been focusing in on some of the, say, shortcomings that we tend to get stuck with. So we focused on things like irrelevant information, when there's information provided that isn't necessarily required to solve the problem. This would be if you're doing, say, a multiple choice question on a quiz, and they give you all this information about the doctor who's running the study and the type of study that they're running, and then the question that they ask you is something about how many participants are there? And so the type of study and all of that was irrelevant. You just needed to be able to count up the number of individuals. So you see that on a lot of tests. And then in the real world, irrelevant information is basically everything that doesn't help you solve that problem. So knowing what is safe to ignore and what is essential for the solution is really important. And we talked about functional fixedness as that concept of we kind of see things only for the purpose that they're intended for. So I think I mentioned the idea of trying to open a package, one of those awful plastic packages. Maybe it's awful enough that it's a pair of scissors in one of those plastic packages you need scissors to get into. And so you look for other scissors or maybe a knife, something to cut it open, but it might not occur to you to use something like a screwdriver, which can apply the correct amount of force to break the packaging, but doesn't actually cut it, so you wouldn't have thought of it when you were searching. And then mental sets, I mentioned that these were when we sort of get fixed in on a solution that's worked for us in the past. And I believe I talked about this in reference to one of our water jug problems. So here, our solution to this question, they give you 3 different volumes of water, and you can sort of fill and empty them as much as you need to. And they say, using only these volumes, we need you to get exactly 100 cups of water in some pitcher. And so for this question, the answer would be you take one of the big ones, take away one of the medium ones, and then take away 2 of the small ones. And then if they gave you a new problem, so same basic setup but with different sizes, and they ask you what the solution is, you would check a solution that has worked before in the past. What if you start with 1 big, take away 1 small, or 1 medium, and then take away 2 small? If that works, you might never realize that there was a simpler solution. What if the numbers happened to work out that you could solve the problem with just 2 of your medium containers? A lot of people will miss that opportunity if they're using a mental set from previous experience. And then the unnecessary constraints that can kind of end up overlapping with functional fixedness, where you don't think to use things in certain ways. But unnecessary constraints mostly focuses in on when we assume that we can't do something or that something isn't permitted. So we had looked at the 9-dot problem, and most people assume that you can't go outside of the boundary of the square that's around all of the dots. But it's never actually stated that that's not allowed. So that would be an unnecessary constraint that you've enforced on yourself. Okay, and so with all of those considerations in our minds, we can move on to talking about how we might go about solving problems. And there's many, many different ways to do this, but of course we're going to try and categorize just a little bit here. And so some of the terminology that's going to help us here, we might talk about the problem space. And this is the set of possible pathways a solution considered by the problem solver. So this is basically saying that here's all of the things that you could do. It's kind of like if you think of working in sandbox mode. It's giving everybody the space they need in which to work. So we can talk about that problem space as all of the possible actions that somebody could take to try and solve this problem. And then for our methods of solving that problem, we can focus on algorithms. And algorithms are something that's fairly useful because it involves systematic trial and error. It's going to be a methodical step-by-step procedure where you might not know what the answer is, but you know all the steps that you can take, and you're going to try them in some logical order until you find the solution. And because of this, because you're going through with a system and it's trial and error, you will eventually arrive at the correct solution. It just might take you a long time. So this is great for trying to find all of the possible alternatives to solving this problem because you're keeping track of how you're solving it. So an example of this would be one of these tower problems. You've probably seen these before. They give you sort of 3 rings and 3 pegs, and you're supposed to move all of these from the first peg to the last peg, so from A to C, but you can only ever place one of the rings on a larger ring below it. So if we moved 1 over to B, we couldn't move 2 on top of 1 because it's bigger. But if we move 2 to C, then we could put 1 on top of 2 over on C. And so there's a set way that you could do this. You could try moving things around in a predictable pattern, and you would eventually come to the solution. However, if you've encountered a problem like this before, then we can start relying on heuristics, which are basically shortcuts. So we can call them guiding principles or even rules of thumb, and they help us approach problems. Unlike algorithms, where we're going sort of systematically and step by step, and there's always going to be a possible solution, with these heuristics, we're basically trying shortcuts to see if they happen to work. They're not guaranteed to work. They might be based on mental sets, so problems that we've solved previously. So there's no guarantee here, but if we happen across the solution, it might be faster than if we relied on algorithms, especially for more complex problems when there's a lot more possibilities. So we focused on that no guaranteed solution thing. We're just doing our best. We might try forming some sub-goals. So we could say, okay, we're going to solve this part of the problem. So even if we go back here and say, okay, well, step 1 is going to be how do we get number 3 over to C? That's the first thing that we have to do. And so to do that, we have to get 1 and 2 on B. So how do we get to that? So you can kind of break it down into little steps to figure out what process you would follow. We might try searching for analogies. Actually, even with our sub-goals, we might try and work backwards, kind of like what I was just doing, where we said to end up, we need C on the bottom or 3 on the bottom. How do we get there? How do we go backwards from there? And then searching for analogies would basically say that we're using a solution from a previous problem to solve a current one. We're using one of those old mental sets in order to sort of help us out in the future. And just like we had said that mental sets can be problematic because we might miss out on simpler solutions, if it gets us a solution at all, that might be good enough. So it might not give us the most efficient solution, but if it works, then maybe so be it. And then one important aspect of problem solving that isn't always mentioned is the concept of incubation. And this is basically that idea of, sometimes you're in the middle of a problem. Maybe you're working through a mathematics problem. Maybe you've taken a physics class or a math class, and there's a particular question and you cannot figure out how you have to approach it. You've sat there, you've spent hours on it, you're just frustrated by now. So you take a break, you go have a shower, you go wash dishes, you go do something that distracts your mind a little bit. And you tend to ruminate, meaning that the back of your mind is kind of working over all the information that you have. Maybe even you sleep on it. And then at some point, you're going to have that moment, that aha moment, where it finally occurs to you, and you go, oh, what if I try this? That's the process of incubation, where you take that step back, you're not actively working on it anymore, but things in the back of your mind just sort of approach it from a different angle. There are some people that think that we do this incubation process while we're sleeping. Maybe that's part of how we dream and sort of reshape things. Lots of different debates on how and when it happens, but I know for myself, I tend to have a lot of really good ideas, especially towards research problems, when I'm doing something mindless like cleaning beakers or switching out bird feeders. It's kind of nice when you're occupied with something else and your higher brain can do something different. And then if we wanted to look at, so this is another type of question, kind of more in line with those math problems I just tangentially mentioned. But this is saying, we have lots of these sorts of things where they ask about, okay, so the trains are moving apart at this particular speed. The trains are moving at whatever speed relative to the ground, and then a bird is moving in a particular fashion. What are the relative distances, or how far do they go, or where are their positions after a certain amount of time? And so you could work this out by breaking it down into individual steps. You could choose little steps that you need to solve. Maybe you want to figure out the position of one train. And then once you have that, you can figure out the position of the other train relative to that. And then the bird relative to both, or something like that. So that's just sort of an example of the process. I don't want to go into the whole question because I don't even think I included it here, but that's sort of one way we can frame it, because most of our examples have been very simple. All right. There we go. All right, and so the next thing I wanted to talk a little bit about was how do we bring culture into this? So we've mentioned that language might shape a little bit of how we think about things. Maybe. But I also mentioned that experience might be a stronger contributor to how we approach things. How do we solve things? How do we think about things? And so culture would be the experiences that we have growing up in a particular place around particular people. So it's kind of like a large-scale version of experience. And so there's been a lot of research that actually looks at sort of how we tend to frame things. And so framing, I think I've mentioned the term, but just in case I haven't, framing is all about how you decide to approach a problem. So if we think about for the next couple of things, we're going to be talking about sort of internal and external frames of reference. So if we're being involved in a problem, so maybe we're trying to remember where something is located, or we're trying to remember how to navigate a particular area. Following directions is a great example for this. So some people have a reliance on sort of internal frames. So they would frame everything as, I'm going to do this, and then I'm going to turn that way relative to me, and then I'm going to walk this particular distance, but it's all relative to where you are at the time. Whereas other people would rely on external frames of reference. So they'd be focusing on the field, so the environment in which they're at. So if you think in terms of, say, a map of the city, and instead of saying, okay, well, I'm here and I'm going to be turning left or right, maybe you think of an overall map of the city and you think, okay, so it's going north, and then we're going to turn east, and then we're going to go, actually east is that way, and then we would go south. So if you're thinking in sort of that bigger picture, not centered on you as an individual, then that would be that field dependence. That's an external frame of reference. And they do actually see differences in different cultures, what they prefer to focus on. And let me make sure I say it right. Okay, so especially in areas where you have lots of ecological demands, so things external to yourself, so survival in the field, maybe you do a lot of outdoors stuff, that ends up fostering field dependence, that relying on external frames of reference. So if you were giving someone directions, you'd probably give them directions relative to landmarks in your environment. whereas other areas are going to have a field independence where they rely on internal frames of reference. And so we typically see that Western cultures are going to more have field independence, or those internal frames. And then we'll see differences in different areas. But again, it's sort of experience and what you're used to and what you're faced with. There are also, I don't know if I get into it, but I've done some work looking at especially navigation in environments. Some really interesting work done by Marcia Spetch at the U of A. And she looks at how different individuals will use different landmarks and how the position and location of landmarks can actually bias your preference for sort of external references versus more internal or close to the body references. So there's lots of neat things like that. And then there can also be sex differences there as well, but not as consistent. So with a lot of these, again, it's whatever you're most used to. I myself tend to rely very heavily on internal references, but I have friends who have no concept of turning right or left at a particular spot. They would just say east or west. And that might just be they grew up in sort of small towns in a lot of farmers' fields and stuff like that, but we can make some stories up that make it make sense.
What do you mean by external frames? Like, any example, please?
So like using a compass direction. So north of the city or south of the city, east or west. So you're considering things that aren't referenced to yourself. So if we're looking at an internal frame, we're thinking, okay, so I'm at that corner and I need to turn right. Or if you're at a particular intersection, if you're using external frames of reference, you say, okay, well, which way is north? So it's what you're using to reference, what you're using to set up your decisions. So are you thinking about your current body position and whether you need to turn this way or that way? Or are you thinking about your location in the world and how you have to move relative to, say, cardinal directions? So internal being a small scale and external being a larger scale. And if you get into navigation type literature, they focus on things like beacons and landmarks, which are just points that you can look at that are closer or further away. And we actually assign different weights based on experience, as well as proximity to the individual, which is kind of cool. But that is far beyond what we need here. Oh, and then this last point, I was trying to figure out why I had included this. A lot of the research that's looked at whether people use sort of those internal frames of reference or external frames of reference, and I mentioned that we see some cultural differences where Western cultures tend to have field independence, which is that internal frame of reference. A lot of people will then argue that that's actually just the difference between individualistic versus collectivistic cultures, where individualistic cultures focus on themselves and their sort of individual environment and things that are around them, whereas collectivistic cultures tend to focus on the big picture and things as a whole. So that would be sort of more of a holistic view as opposed to an individualistic view. So that's what that point was meant to say, is that it might be related to other things that you might see talked about a lot more if you keep on into 105. All right. And then when we start into the proper process of actually decision making, so we're going to say that a lot of human decision making strategies end up being fairly simplistic. And if we look at it logically, a lot of the choices that we make might not be entirely rational. I've already mentioned that we tend to persevere on previous mental sets that have worked. So if we've found a solution in the past, we tend to persist using that solution, even if it's really convoluted. As a lab worker for quite some time, I saw some of this, and it ends up looking a little bit like superstitious behavior. So maybe you're trying to set up a new experiment and it's not working, and then you start trying random things to see what helps. And then you notice that in the batches where you stir clockwise versus counterclockwise, it seems to go a little bit better. And now that's part of your protocol. And everyone who comes to the lab after you knows that you have to stir clockwise versus counterclockwise. And it sounds ridiculous because it is ridiculous. It was probably just a chance occurrence. But you would be astounded at how many lab manuals include very strange instructions like that just come from, hey, it worked once, we don't mess with it. So we tend to stick with solutions that work, even if they are not logical. And that could be some of our quirks and complexities, because sometimes when stuff stops working, we try new things. We see what works next and we stick with what works. And so we can end up with much more complex and convoluted solutions than what we really need. I've also experienced this even just in a workplace. So I went and I worked with the federal government for a little while in between my degrees, and I was helping them basically put data in a spreadsheet so that they could look at all the different sites that they were trying to clean up in order to release back to the public. So they were cleaning up lighthouse sites. And they had an archaic system of taking the data that they were given, they would print it out, they would get somebody to manually type it into another spreadsheet, and then they would print that out, and then they would give it to someone else who put it into a database. And to them, that was a perfectly functional solution. It had worked for years and years. And at the time, there was a reason for doing it. There wasn't a convenient way to get the information from one point to the other without that convoluted step. But when I got there as a new person, and it was like, well, why don't we just do this? Take the information and put it straight in the database. And it just didn't occur to people. So there was that added complexity and strange little quirks that from the outside don't make any sense. So just a couple of examples there. All right. And so there's a couple of things that we can focus in on. There are different strategies that we can be using when we decide on which direction we're going to take with a particular problem. And of course, if we go into more research on decision making and problem solving, you can talk about different theories of how we weight things. So you might see things like the expectancy theory or expectancy by value theory. And that's basically where we take into account what people expect as the outcome. So a lot of the research that looks at decision making from that point of view would say present two buttons. And if you push button 1, then you have a 50-50 chance of winning 10 points or winning nothing. And if you press button 2, you are guaranteed to get 2 points. Which one do you press? And so we could say, okay, well, if we just look at the odds, we have sort of a guaranteed 2 or a 50-50 on, I can't even remember what I said already, but the average for the risky choice is actually better. So logically, you should take that option. But if we frame it instead of as a gain, but as a loss, then we can actually end up seeing people flip their choices. People would much rather take a little bit of risk in order to not lose things, as opposed to guaranteed lose things. So we can use that understanding of our expectancy and how much we value things. So a loss of something, like losing money, is really bad, and people try and avoid it as much as possible. And then gaining, it's good and all, but it's actually a little bit better. We would rather the sure thing than not sort of taking risks there. Okay. So yeah, so that making choices based on risks and uncertainty, we can call that just risky decision making. And we can frame things as gains or losses, and we will treat them differently. We might also look at subjective utility. So that is specifically what something is worth to you. So maybe there's a chance to win a particular prize in a raffle. And if it's a prize that you actually want, then maybe it has a lot more value and utility to you. But if somebody else already has that or has no use for that, then they're not interested at all. So that relevance to yourself can influence your choices. So whether or not you actually participate in the raffle will depend on what the outcome could be for you. All right. And then, of course, we take all of that and put it together into the concept of subjective probabilities. And this is basically when you figure out probabilities through experience. So I mentioned pressing the buttons and having one being a guaranteed win and one being a 50-50 between a win and no difference. If we don't tell people outright what those probabilities are and just leave it to them to figure it out, they actually tend to be very, very bad at guessing what the probabilities are. And the reason for this is that people tend to over-remember the extremes. So they will remember winning lots of money, and they will remember losing lots of money. And so those things become more heavily biased in their memories. And the really cool part, going back to that research I mentioned earlier by Marcia Spetch, she studies gambling in humans, but also in pigeons. And pigeons are really, really close in their behavior to humans when it comes to making risky choices, but also when it comes to over and underestimating probabilities. So it's always really important to keep in mind that even if we know the probability or think we know the probability, we don't necessarily weight it evenly, just due to that sort of pesky human deviation from logic. All right. And then a couple of heuristics that we have. So these are things that actually can be sort of holding us back when we're trying to make decisions. So these can be shortcuts that end up not being as useful as they could be. So something like the availability heuristic. And this is basically saying that when we estimate the probability of an event, we overestimate things that are memorable. So I guess if you're trying to think of the divorce rate in Canada, and then you think about, okay, well, of all of my friends, this many of them, their parents are divorced, so therefore the divorce rate must be that. So we're making these assumptions based on personal experience, things that we've sort of encountered recently ourselves. We also have a representative heuristic. So this is basing the estimated probability of an event, these are all looking at estimating probabilities of events, on how similar it is to the prototype of that event. Basically saying, is this the same as the average for that particular event? So this plays into our tendency to ignore base rates. So if we would say that Steve is probably a librarian, because he looks like a librarian, rather than Steve is a librarian because librarian is the most common job to have. So you kind of show that, oh, like he looks like that role, so he must be in that role. Or this individual sort of acts in this particular way, so they must fit within that particular group. So you ignore what we know as a baseline. So even if we had told you the statistics where 5% of people in this group are librarians, which ones are they? You'd be more likely to sort of overrepresent them if there were a lot of librarian-looking people. So we have lots of those kinds of biases. All right. And that did tie us into that tendency to ignore base rates, where we don't always consider everything that's relevant when we're making some of these decisions. And we can actually find that we end up with very illogical information. So if you do things like asking people what proportion of the population fits into each of these categories, people end up making up a total that is not up to 100%. So they'll end up sort of not quite considering how things should be working out. So stuff like that's always important to consider. And then, the conjunction fallacy, that's another one where we're looking at trying to estimate the odds of a particular event happening, but now we're considering two uncertain events happening together. And this is basically saying that we kind of start thinking that these two things happening together ends up being more likely, even though if you've ever taken a math class where you talk about probability, if we say the probability of event A is 1%, and the probability of event B is 1% as well, when you say what's the probability of both all things being equal, you'd actually multiply that 0.01 by both of them. So you would end up with 0.0001. So it would end up being much, much smaller. So you should say that the probability of these two things happening in conjunction is even more rare than them happening on their own. But again, if we ask people to report what they think the likelihood is of these two events happening, they actually say that it's more likely for them to co-occur than it is for them to occur on their own. And a lot of the data that you'll see talking about this is asking, what are the odds of this person being a librarian? Or what are the odds of them being a salesperson? And then what are the odds of them being a librarian and liking books? Even if we give you the probability of being a librarian and the probability of liking books, they still assume that doing both is going to be a much higher probability. And the text gives them a lot of better examples of that than I do. Okay. Oh, and then this is just the figure that the text uses to talk about the conjunction fallacy. So if you wanted to read through that, this would be a good spot to start. Okay. All right, and then we're going to talk our last two slides. We're going to look at behavioral economics, and then we're going to talk about evolution and how we can look at human decision-making processes. And so behavioral economics is almost like the crossover between psychology and economics, where we start looking at how the effects of decision-making or of our decision-making process in terms of the economics of our behavior. So what are the outcomes? What are the gains? What are the losses? And so if you actually get into behavioral economics, it's kind of like looking at decisions from the frame of an economics text. So lots of equations, lots of probabilities, and lots of sort of looking at those outcomes. And so the theory of bounded rationality says that people tend to use simple strategies in decision-making, and they tend to focus in on only a few facets of their available options. So when we're making these choices, we tend to use simple models that can be easily represented with only a few terms. And because of that, because we ignore the complexity of all of the choices available to us, we tend to make decisions that end up being sort of logically irrational because they're based on only a subset of what we should theoretically be basing our choices on. And so we've seen some of those biases, especially when we're talking about framing. If we're looking at sort of, is this something that applies to myself? Am I framing this as a gain or a loss? There are some really neat logic puzzles, and sometimes in classes that I've done before, I used to do sort of interactive clickers in some classes before it was weird to touch a lot of things in class. But I'd put up a situation where they talk about perhaps there's a new drug that would offer this much success in fighting a particular disease. And if we frame it in terms of this many people would be saved, and then you can kind of infer how many people would not be saved. A lot of people are more in favor of saving a few people, even if there are a lot of people that are lost that aren't mentioned. But if we ask the exact same question with the exact same numbers, but frame it as we lose the same number of people, and we leave it for you to infer how many are saved, that negative framing will almost entirely shift the response. So in a classroom, you'll actually see going from, I've done before, like an 80% approval rate to an 80% disagreement rate, just from changing the wording. So the way that we frame things, the way that things are presented, can completely overhaul how individuals respond to it. And that's why it's really important to consider things like polls, questionnaires, and surveys. If we think back to our Chapter 2 discussion on methods, when we ask questions, the way in which we ask those questions can actually influence the outcome. So we need to keep that in mind. And it comes down to a lot of people will consider things in particular ways based on only the information that they're given, not necessarily all possible available information. All right. Okay. Oh, and I included this because I thought it was really interesting. So I mentioned talking about Marcia Spetch's work. Dr. Spetch works at the University of Alberta, and I actually ended up being able to work with her quite a bit. She's very, very interesting, studies navigation, which I find ironic because I took a class on decision making with her, and her first story was about how she got lost in the desert for 6 or 8 hours the first time she went, because she was so focused on taking pictures that she wandered off and had no way to get back. But it sort of plays into the idea of you study what you can't do yourself. But in that class, she actually had us read a text called Thinking Fast and Slow. And it approaches this duality of how we approach problems, where if we rely on algorithms and logic, we can get to the right answer eventually. It's a long, time-consuming process. It's going to be taking a lot of mental power to get there. But if you have a systematic strategy, it's going to work in the end. Or we can go with fast thinking, where we rely on heuristics, when we rely on mental sets and existing assumptions. And we aren't guaranteed a solution, we aren't guaranteed the correct answer, but it's a lot less mentally intensive and a lot less resource intensive. So it's kind of like when we were talking about that automatic processing, which happens to be very fast but also static, or our conscious, effortful processing, which was much slower but more resource intensive. And we do that for a lot of different things. It's not just our consciousness and our focus, it's our active decision-making process. And I just thought it was interesting because when I saw this mentioned in the text, I looked back and I have this book on my shelf, which was kind of neat. So I just figured I'd include it for that reason. And yeah, so they're saying here, like at the bottom, we have our quick and dirty heuristics where they're basically less than perfect, but they're adaptive. They're based on our experience. Find a fast solution, perhaps. Or taking the long way around, taking our time and getting there eventually. All right, and then the last thing I forgot about this slide is just some of our pitfalls in reasoning. And this is basically going to highlight some of the key points that we tend to sort of overlook. And this is going to be a lot of the same of what we've been talking about already, just now with proper names. So the gambler's fallacy is the belief that the odds of a chance event end up increasing if that event hasn't occurred recently. So it's based on the idea of, say, sitting at a slot machine and you're like, well, I won once at the very beginning, but it's been a really long time since I've won. It must be my turn soon. I must be getting that chance soon. But if we think about it logically, something that's based purely on probability, every time you pull that lever, there's a 1 in whatever number chance of receiving the prize. And that 1 in whatever chance is the same every single time. So whether it's happened recently or not doesn't actually change the probability. The probability is always the same. So it's another one of those framing problems where they assume that, oh, well, it hasn't happened for a while, it must be coming up soon. Not necessarily. The probability doesn't change. You could theoretically get 2 back-to-back, just based on odds. So it isn't necessarily tied to that timing. We also have the law of small numbers, and this basically says that people assume that results based on small samples end up being representative of the whole population. So this is, again, kind of like, okay, I'm thinking about a concept, so I'm going to think about how this concept relates to my small friend group. Of my 10 closest friends, how many of them have divorced parents? All right, well, that must be how many people in the population who have divorced parents. So if you have a 50-50 split, then that must be representative of the whole country. But as we talked about with small samples when we were looking at our methods, having a small sample means that it's really easy to have a biased sample. What if you happen to have a bunch of friends who all became friends because of sort of the trauma of your parents divorcing or something like that? What if you all have divorced parents and that's part of why you're friends? That would be sort of a misrepresentative sample. And yet again, because of logic, people assume that even small samples will then apply to the larger population. We also have a tendency to overestimate the improbable. So we think that things that are sort of dramatically unlikely to occur, that they must happen every once in a while. So we would overestimate the probability of an event. And there's a bunch of reasons that will do that. I don't think I've mentioned it here, but things that are especially salient, meaning that they catch your attention, we tend to overestimate them. That's why people assume that a lot more individuals die due to shark attacks than they actually do, because it's a very improbable event, but anytime anything even remotely close to that happens, there's big news headlines about it. So we assume that it happens more often. In fact, people are much, much more likely to be killed by cows or vending machines, but that doesn't make the news, so we underestimate the probability of those events and overestimate the ones that we hear about more often. We also have an issue with confirmation bias and belief perseverance. And this is basically, again, another human problem where we tend to look for information that supports our pre-existing beliefs. So if we can have a confirmation bias in research. So if a researcher has this assumption, a hypothesis, that event A causes event B, and they're setting up an experiment, they might be more likely to ignore information that goes against that hypothesis, and they'd put more weight behind things that support that hypothesis because that's what their beliefs are. And we mentioned this with our researcher bias at the beginning, where it's something that we might not even be aware of. If we have, say, ambiguous information, maybe we're scoring whether something happens or not happens, and we have an ambiguous behavior. If we know what group that person is in, we're more likely to score that ambiguous behavior in a way that matches the hypothesis we're working with. And again, it's not intentional or malicious, it just happens. And this goes along very well with the idea of belief perseverance. And this is basically once we think that something happens a particular way, once we have a particular idea or have made a particular decision, it takes a lot more evidence to get us to move away from that than it would have if we started out with a neutral opinion. So if, say, you had taken a psychology class previously and you had been taught psychology in a very, very different way, with very different facts, it might take more effort to convince you that my way was correct than someone who comes in and has never taken psychology before. Because with nothing else to sort of base your decisions around, you would take information from a fairly reputable source, backed by a fairly reputable textbook, and say, yeah, this is probably reasonable. But if it goes against something that you already know, you're more likely to question it and push back. And so it's a lot harder to get somebody to change a belief. And then we also have the overconfidence effect. And this is basically when people assume that they're really good at estimating things. So when they do those tests that ask people, okay, well, what proportion of the population belongs into each of these categories? People are fairly certain about it. And the more you ask them about it, the more certain they get about their decisions, despite the fact that people are notoriously awful at estimating things like that. So a lot of these studies, they tend to be very inaccurate, but people are very sure about those inaccuracies. All right, and I already talked about framing quite a bit, so I don't want to say any more on that. But yeah, so that's just some of the things we need to keep in mind in how we frame information. Kind of an interesting place to end off the course. Like I said, I'm not used to teaching this topic in this class, but I kind of like it. So I said last time that we would finish today, which we have, and that means that on Friday, I'm going to be coming in and just hanging out in the classroom, no structure intended, but if you have questions, if you have concepts that you want to go over, we can absolutely do that. I'm not preparing anything, so if you have topics you want to cover, maybe write them down, have a list. But I'll just have access to all of my old slides, and then that way we can sit and go through whatever you'd like to go over.